One of the most common things we are finding in calculus is this thing called the derivative. The derivative measures the rate of change of a function at any given point. So to kind of get a look at, by definition, what we're really doing is first we're going to take a look at this thing called the secant line. The secant line is the average rate of change or the slope between points. So for example, if I've got a graph here, maybe it looks something like this, and we want the average change from this point on the left to this point on the right, that would be the slope of the line that connects them. So if this point is at x, it's going to have a height of f of x. And if we move over some distance, we'll call that h. We end up at x plus h. And it has a height of f of x plus h. In other words, we have 2 points on this line. The points are x comma f of x and x plus h comma f of x plus h. If we were to find the slope between these 2 points, we would take y2 minus y1 over x2 minus x1. Notice when we do that, though, the x minus x can kind of subtract out to 0. So really, the slope of the secant line is the f of x plus h minus the f of x all over h. However, we're not actually interested in the secant line, the average between 2 points. We want to know more about the slope of the tangent line. The tangent slope is the slope at one point that measures the instantaneous rate of change. How fast is it moving right now? The idea of this is we had this distance of h between the 2 points. We're going to take the second point and bring it down closer and closer to the x. In other words, this distance of h started out as this large h, but we want to make it shrink down smaller and smaller and smaller, all the way down till we get this point at x with a height of f of x. And we want the line that's going to be tangent to that point. In other words, it's just going to kiss the curve at that point right there, barely touching it. And the way we get that is we take that h and shrink it down to 0. In other words, the slope of the tangent line is equal to the limit as h goes to 0 of that secant line. So we would have f of x plus h minus f of x all over h. This is the definition of the derivative. Now, a little bit of notation, though, just so that we know there are lots of ways to write we want the derivative of that thing. The derivative of either f of x or some equation y, it can be written in lots of ways. And so you should recognize all of these as really being the same thing. It really depends on who developed. This notation might be just a little bit different depending on that context. So one common way is we'll see the f of x with the little prime apostrophe up next to it. Another way that we see it is they just use a y with the apostrophe next to it. Another way we see it is d over dx. That stands for the derivative with respect to x. And finally, another way that we see it is we might see dy dx, which means the derivative of y with respect to x. These 4 notations all mean the same thing. They all mean that we want to calculate the limit as h goes to 0 of f of x plus h minus f of x all over h. That's the theory behind what we're doing. Our next video is going to actually look at calculating derivatives.